Okay, so let's get started. I'll be back in class on Wednesday and Thursday, but until then, let's go ahead and get started on what the next lesson is. You remember back before Thanksgiving that we talked a lot about vertex form, and this is really just everything that we've gone over. We learned that y is equal to a times x minus h squared plus k, and that the graph of that was going to be a parabola opening up. We learned that the vertex was h and k, and remember those are specific values for x and y that give us the turning point right here on the graph. Our axis of symmetry is always x is equal to h, and that our range depends on whether we have a maximum or a minimum. In this particular graph, this little sketch, you can see that we have a minimum, so that we know that y values will always be greater than or equal to k. If it were opening down, like this, then we would know that y was always going to be less than or equal to the point right here. So this, on finding a minimum and a maximum, is really a piece of logic thinking. What is my y value going to be? Is it ever going to be greater or smaller than this? We learned that a, our very first coefficient up here, is simply going to tell us if we're going to have a stretch or a compression. Remember, if a is greater than, if the absolute value of a is greater than or equal to 1, then you're going to have a stretch. If the absolute value of a is less than 1, then you're going to have a compression. If a is positive, the graph will open up, and if a is negative, the graph will open down. So all of these become tools to help us better draw a graph to more accurately understand what a function's doing. And this is how we look at everything in vertex form. In many of the classes before break, we briefly looked at what we call standard form. And standard form is ax plus ax squared plus bx plus c. Okay? And so what I want you to see here is these are the ways that we find the same things that we were finding in the vertex form. We find h by plugging it into the equation of h is equal to the opposite of b, that's where we get b, over 2 times a, and this is where we get a. Once you find h, then you're just going to plug it back into your original equation, and you're going to get k. And that is why we say that k is equal to f of the opposite of b over 2a. What we're saying is k is whatever y becomes, or the function of whatever you put h in, whatever h value that you put in. And we'll do this. Confuses students because of all the letters and stuff from time to time. So what we're going to do is we're going to do a few of these soon. Once we find out k, then we can determine if we have a minimum or a maximum, and what that minimum or maximum is, and then what our axis of symmetry is. These are all the same. Your minimum and maximum and your axis of symmetry, those are the same things. The h and k is your vertex, which we've been doing. So the only difference really is how we find h and how we find k. One thing that helps us to graph is also, now we know that c is the y-intercept. This number right here is where that graph, say it goes like this, c is where that graph crosses the y-axis. So that actually gives us another point to graph. So let's look, let's go ahead and look ahead. We're going to look at a couple of problems, and one is y is equal to x squared minus 4x plus 1. We find that h is equal to the opposite of b over 2a. And we go ahead and we just fill in the blanks. We fill in for the variables. That's all we're doing here. It's a matter of substitution. So what we find out is that h is going to equal 2, and here is where all of the writing and all of the variables becomes very easy to do, because what did we do here? We just simply substituted whatever we got the 2, and we just went to find f at 2. And we've been doing this since chapter 1, and we just substitute 2 into the equation for wherever that we had the x. And we find out that our vertex is 2, negative 3. Our axis of symmetry is x is equal to 2. We have a minimum at y is equal to negative 3. Our y-intercept is y is equal to 1. And we're moving on. So here you see I've taken the time to write A, B, C. As you get in the habit of doing this, this is a strategy that you might want to use. And we just go through the process again of solving for H, solving for K. Our vertex is 1, 4. Maximum at y is equal to 4, and we know that because our axis of symmetry, we know that because we can tell that it's going to be opening downward. We know our y-intercept is going to be at 3. You can see that it's just a matter of identifying A, B, and C, and then you plug them in, and you plug them in, and then you start drawing your conclusions. So for each of the ones that are going to be listed on the next page, I want you to find the vertex, which means H and K, the axis of symmetry, whether there is a minimum or maximum, and what is the minimum or maximum, and then what is the range. What are the possible y values? Does it open up or open down? And what is the y-intercept? And these are the simple problems that I want you to do. And we will go over all of these when I return to class next. If you need more help on these, you can always Google graphing equations using standard form, or graphing quadratic equations using standard form, and you'll be able to find some other videos using that. Otherwise, I will see you and your assignment on Wednesday or Thursday.